This lesson is over solving algebraic expressions, and we have here the definition of an algebraic expression. This is a mathematical phrase that's made up of numbers and variables, of course, are the letters that we have in the problem. So we've got this arrangement of numbers and letters, and then we're going to say that each letter has an assigned numerical value, and then we're going to plug those numbers into the letters for the variables, and we're going to solve so that we get a number answer. And that's what this definition in red is saying. We're using substitution property. It says if A equals B, then A, may be replaced by whatever B is equal to in any expression. So that's just a way of saying, like, whatever value or number is assigned to a letter, we're allowed to substitute or plug it in for that letter and solve. So we have our steps down here on how to solve or evaluate an expression with variable replacements. First, we're going to substitute the variables with their given values, but we have to remember that each time that we substitute a variable with a number, we have to put parentheses around that number, and that really will make or break this whole situation, whether or not you're willing to use parentheses. And then it says that you should use order of operations to evaluate, and I'm going to show that if you use parentheses correctly to plug in your values or substitute them, that you do not even need to use necessary order of operations. If you can use parentheses correctly, you can show that on your paper, then you can jump to plugging it into your calculator, okay? So looking at our first example, we have AB squared plus C. That's our algebraic expression here. And what we have to the right of that, it says if A equals 2, B equals 4, and C equals 7. So we've assigned these numerical values to A, B, and C, and what we need to do is substitute them in for their corresponding letter value or in the expression. So the first thing that I always want you guys to do is rebuild this expression by replacing every letter with parentheses first. And everything else about it that's not a letter should be in the same place. So here's what I mean. We have A, so I'm putting parentheses for A. And then right after A, we have B, so I put parentheses. And then I had squared that came after B, so I'm putting the squared right after the second set of parentheses. And next, I still have my plus sign, just like I did. And then I get to another letter, C, so I'm still using parentheses in place of that variable. Because if I don't use parentheses, I could get this all wrong. Now at this point, I'm going to make sure I match up the right number to the right set of parentheses. If A is equal to 2, my A was first, so I'm making sure I put 2 in the first set of parentheses. I said B equals 4, B came second, so I'm putting 4 here. And last, we said C equals 7, so I put 7 in that last set of parentheses. Now at this point, you could keep working this out by order of operations like we've already learned, or if you prefer, you can go to your calculator at this point. You would plug it into your calculator, type it in exactly like this with parentheses and everything, and it really doesn't take that long to type in a parenthesis, than it does by working it by hand. But if you type it in exactly as I have it boxed up right now into your calculator, you will get equals 39. And that is the correct answer. You should, if you're working order of operations, you should have done your exponents first, so you would have had 2 times 16 plus 7. Then we should multiply 2 times 16, which is 32, and add 7, which equals 39. So whether you're using your calculator or working it out by order of operations, you should get the same answer. If you like working it out by hand, I still recommend typing it into your calculator to check. But again, if you don't have parentheses around everything, you could end up with a wrong answer. And I'll show that on number 2 here in a minute. So on number 2, we have the algebraic expression 3x squared minus 4x. And we're saying if x is equal to -2. So I'm still going to rebuild this expression by replacing all the variables with parentheses. So we have 3 parentheses, a squared sign after it, minus 4. There was an x, so I put another set of parentheses. I only have one variable here that we're assigning a value to, and that's -2. So I'm putting -2 in each set of parentheses. Again, this is the work I would expect to see, that you know how to use parentheses correctly. Okay, so this again could be typed into your calculator, just like this, parentheses and everything, and we get equals 20. Now, what happens if you don't use parentheses? Let me show you. If you typed it into your calculator, 3 times -2 squared minus 4 times -2, no parentheses, I'm just typing in all the buttons like I see it, this would tell me it equals -4 in my calculator. It used a different set of order of operations because I did not use parentheses. This value, net -2 squared, means -4. And up here, -2 in parentheses squared means +4. And it doesn't seem like it would make a very big difference just having that one sign changed, but it really does. Obviously it does, because the correct answer is 20, but if you didn't use parentheses, you get -4, which is incorrect. So parentheses really do make a big deal. It's the difference between getting the correct answer or getting the wrong answer. Okay, number 3, we have a squared b minus b squared if a equals 3 and b equals -4. So again, first step, rebuild it by using parentheses to replace each letter. So I have a, so parentheses, squared, then b, another set of parentheses, minus sign, there's a b squared, so you put parentheses and the squared goes on the outside. Notice that all the exponents go on the outside of the parentheses. Same thing with all these signs. The only signs that get to go inside the parentheses is if the a or b value themselves have a negative sign with them. So all of my a's are 3. I only have one a, came in the first set of parentheses. And then my b values are -4, and we had 2 of those, so we use -4 here and here. So we plug it into your calculator. Again, exactly like this. We'll go over that more in class on how to make sure you know where all the right buttons are, but that equals -52, and we're done. Okay, on number 4, we're actually using the very same algebraic expression as we used in number 3. It's a squared b minus b squared. So these two things are the same, but we've changed up the assigned values that we're plugging in for a and b. This time we're saying a is equal to 4 and b is -7. And even though we're using the same expression, because we're using different number values for those variables, we get a different answer. So my process hasn't changed. I'm going to rebuild it using parentheses. So parentheses squared, parentheses minus parentheses squared. My a is 4 this time, so that changed. And my b is -7. So -7 goes here and here. Now, again, type it in just like that, and we get -161. Exactly. On number 5, our algebraic expression is -y squared minus 3xy. So notice I've got this negative sign before the y. So when I'm rebuilding this using parentheses, that first negative, it's outside the parentheses that I make for y, and it needs to be that way. Okay, signs, the only sign that's allowed inside the parentheses is if over here on the right, one of those numbers is negative. Other than that, they stay outside the parentheses. So negative parentheses squared minus 3, and then 2 sets of parentheses follow. Okay, we're saying that x is equal to -4. So the only x I had came after 3. It's right there. And then our y's are equal to 2. So we have a y here and here. Again, this is calculator work. It can be done order of operations, but you don't need to. Okay, I can show it that way more, but even if you are working out by order of operations, know how to appropriately plug it into your calculator. It needs to look exactly like this. Hit equals, and we get 20. Again, I can show the order of operations First we would do our exponents. 2 squared is 4, but the negative was outside, so we have negative 4. And then we have minus 3 times negative 4 times positive 2. Those are all being multiplied together. So we have 2 times negative 4 is negative 8, times 3 is 24. So we have minus a negative 24. Those two negatives would become positive, so negative 4 plus 24 would still be 20. So they both check out. Now it's possible to do it both ways, but I'm a big fan of using your calculator whenever you have the chance. Okay, number 6, we have this, again, it's the same algebraic expression as we had on number 5. It's negative y squared minus 3xy, but this time we are substituting in different values for x and y. This time x will be a fraction, negative 5/6, and y will be negative 12. I start the same way. I have negative sign, and then my parentheses, and my squared sign comes outside the parentheses. Minus 3, and then parentheses, parentheses. Y is equal to negative 12. So I'm putting it negative 12 here, and x was negative 5/6. Again, same thing. We'll go over where that your fraction button is, but I believe you're all familiar with it at this point. Type it in, and this equals negative 174. On number 7 and 8, we're being given the same algebraic expression to solve for each, just assigning different values for each problem. But notice we have an algebraic expression that is set up as a fraction. So it's basically the same thing. Depending on the type of calculator you have, we'll go about solving it in a little bit different way. We'll discuss both. We're still setting it up by replacing our variables with parentheses. So notice we got a fraction here. And in my top, I have a squared plus b squared. So I'm going to have parentheses squared plus parentheses squared in my numerator in the top. And in the denominator, I have parentheses minus parentheses. Okay, let's plug in our values. Every a is equal to 3. So we have an a here and here. That's where we put our 3's. Our b's are equal to 4. So here and here. Now, if you have a Casio like I requested, you would hit the fraction button first, and then you just fill it in. To the top, you fill your top in, push the down arrow, fill in the bottom, hit equals, and you're good to go. That's if you have a Casio. If you have a TI, you need to do it a little bit separately. If you have a TI, you need to solve the numerator first down to one number. So that means I would type in only 3 squared plus 4 squared, and that would equal, in the top, that would equal 25. And then I would type in the numerator, or the denominator, excuse me. Okay, and the denominator is 3 minus 4. And that equals negative 1. So this is my 25 is the top, negative 1 is the bottom. So then I would just divide it at the very end with your t. I do 25 divided by negative 1, which is equal to negative 25. So if you have a TI calculator, it's a lot harder to set it up and make it look exactly like this. You can do this if you have a Casio, what I circled. If you have a TI, then you have to break it apart and solve it in sections. Numerator down, typed in, equals, then get an answer for the denominator, and then divide those two parts. On number 8, so let's kind of cut this in half. Rebuild it using parentheses. So a squared plus b squared over a minus b. Now we're using some negative numbers for our a and b values. A this time is negative 3. And b is negative 5. So here and here. Again, if you have a Casio, okay, if you have a Casio, then we're going to be able to type it in exactly. Again, push the fraction button first, fill in your numerator, push the down arrow, fill in your denominator, and equals, and this comes out to 17. If you are using a TI, okay, the numerator, when you type it in, it equals, let's see, it equals 34. The denominator, when you type it in. That -3 minus -5, that's going to come out to +2, excuse me. And then you would type in 34 divided by 2 to get 17. So you get the same answer, but using a TI just will take a little bit longer. But it's totally doable. Or you could do it by hand. Lots of fun. Okay, number 9, we're using 3 different variables, and we've got some parentheses already in the problem for 9 and 10. So it's going to be some good times right here. So number 9, I have x squared minus 2, and then I have parentheses x minus y, so that means it's going to be multiplied to that, minus z cubed. So I'm still starting off the same way, rebuilding the algebraic expression by replacing my variables with parentheses. Ooh, it's floating around here. Okay, we have parentheses squared minus 2, and I'm going to show this first set maybe a little bit bigger, and then I have x, so parentheses minus y, close it up with the parentheses that were already in the problem above, and then minus parentheses for z, and then the cube sign outside of it. And in your calculator, when we get to these parentheses, it's fine. You just have 2 parentheses in a row, basically, and it works out just fine. It's the correct way to plug it into your calculator still. So our x's are equal to +2, so I have a 2 here and here. Those were where I had x's. We have 1y, it was equal to -2, so we're going to plug in a -2. And then we have 1z at the very end, and z is equal to -3. So again, this would still be the correct way to type it into your calculator. You're just going to have 2 parentheses going, open parentheses we would call it, starting parentheses, and then close this one. And when you get here, just make sure you close it. Again, we'll have 2 closing parentheses here and here. When you type it into your calculator, hit equals, and we get 23. Voila, it's like magic. We love calculators. Okay, number 10, we have the same expression, but we've assigned different values. This time we're saying x is -3, y is 4, and z is -1. Let's see how that changes our answer this time. So x, so parentheses squared, minus 2, parenthesis because of what came after the 2, and then we have x, so I have another set inside, minus y, close it all up, minus z, parentheses cubed. Our x's are -3, so we have x's here and here, -3, -3. Y is 4, there was 1 y, and z is -1 at the very end. Again, I'm trying to really emphasize that this can just be calculator work. Now, what I would expect to see on your homework or your notes or any worksheet that we did or on an exam, I would expect to see you rebuild the expression by using parentheses and plugging the values in correctly, and then you can type it into your calculator and jump to your answer, and this is equal to 24. Okay, our last 2 examples, numbers 11 and 12, we have the algebraic expressions -a squared minus 2bc minus the absolute value of c. So first I rebuild using parentheses. Negative and then a squared is negative, and then parentheses squared. Minus 2, so the 2 goes there, and then bc, parentheses, parentheses, minus the absolute value of c. So I put those absolute value bars. We then plug in our assigned values. We have an a is -2. Our b's are 3, so we have 1b, we put a 3 in its place. And then c's, we have 2 c's, and c's are -3, so -3 here and here. Now the one little difference for this part is that there is one version of the Casio calculator that does absolute value bars, but a lot of calculators don't. So we will just kind of work out the part that has the absolute value. We'll change that so to show what you would plug into your calculator. So we would have negative and -2 squared minus 2 times 3 times -3. But what is the absolute value of -3? When it comes out of here, it's +3, but then there's a negative on the outside, so it goes back to being -3. Okay, just because there's not an absolute value button on a lot of calculators. And then from there, now you have what you need to type into your calculator. And this comes out to be equal to 11. Okay, same thing for number 12. We're going to rebuild it using parentheses, so negative parentheses squared minus 2, and then 2 sets of parentheses minus the absolute value of c. This time a is negative 3, so we're putting in negative 3. B is equal to negative 5, and c is equal to positive 2. Okay, so again, just checking out this part. When 2 comes out, it's still positive 2, but there's a negative on the outside that's changing it still to negative 2 or minus 2, which is the same thing. So what we're typing into our calculator will be negative 3 squared minus 2 times negative 5 times 2. And then type this all in to your calculator, showing that this minus 2 has been pulled out of its absolute value bars. This is equal to positive 9. Now the big takeaway from this lesson is that you really need to use parentheses whenever you're plugging in numbers for variables. Okay, no matter what type of algebra you're doing, that's how you eliminate mistakes. It doesn't take too long to do, and then you can use your calculator, and it's more worth it to get the answer right instead of doing it wrong and then having to go back and correct it by using parentheses in the first place. So there you go. Good luck.